In this reaction, aromatic aldehydes can be prepared by treating benzene. Aromatic aldehydes can be prepared by treating benzene with hydrogen cyanide and hydrogen chloride. Hydrogen cyanide and hydrogen chloride. In the presence of aluminum chloride, in the presence of aluminum chloride, so this reaction is called as Gattermann synthesis. Now, for example, benzene react with hydrogen cyanide and hydrochloric acid or hydrogen chloride. Hydrogen cyanide and hydrogen chloride. In the presence of Lewis acid or in the presence of Lewis acid, that is aluminum chloride. To form benzaldehyde. Now this benzene react with this hydrogen cyanide and hydrogen chloride. In the presence of this aluminum chloride, it gives benzaldehyde. Now here plus NH3 plus HCl. Now this is benzene. So this is the reaction of Gattermann synthesis. Now mechanism. Step first. Hydrogen cyanide and hydrogen chloride react in the presence of aluminum chloride to form carbonium ion. Now, this hydrogen cyanide H C triple bond M plus H, this Cl, in the presence of this AlCl3, now this Cl minus is combined with this AlCl3 and this bond is transferred on nitrogen atom. Nitrogen carries negative charge. Then this H plus ion combined with this nitrogen atom and this carbon carries a positive charge. So HC, now this carbon carries positive charge, double bond this NH, and this is the formation of carbonium ion. Now plus this AlCl4 minus, this Cl minus combined with this AlCl3 to form the AlCl4 minus. This bond is transferred on nitrogen atom. Nitrogen atom carries negative charge while this carbon carries a positive charge. Now this negatively charged nitrogen use one electron to this H plus ion to form the bond between nitrogen and hydrogen and form the carbonium ion. Now step second. In the step second, carbonium ion combined with carbonium ion combined with benzene to form pi complex. Now this benzene now this bond is transferred on this carbon atom. So this carbon becomes negative charge and this carbon becomes positively charged. This carbon becomes negatively charged, this carbon becomes positively charged because this pi bond is transferred on this carbon. So one electron is less on this carbon, therefore this carries positive charge and this carbon carries negative charge. Now plus this carbonium ion, this CH double bond, this NH, this carbon is positively charged. Now this positively charged carbon is combined with this negatively charged carbon to form a bond between carbon and carbon and to form a pi complex. Now this CH double bond is NH. Here H, here also this H. So this is the formation of pi complex. This is the pi complex. And this is benzene. Now fourth step. Pi complex hydrolyzed with water to form hydrolyzed with water to form complex second. So this pi complex is hydrolyzed now. This is hydrolyzed with water. So addition of water takes place like this H2O. So O is linked with this C double bond O, and this is the NH3. Now this is the complex second. And the last step, complex loses a proton. Complex loses a proton to form benzalate. To form benzalate. Now this complex second loses a proton. Now this H plus sign is loses, and this bond is transferred in between these two carbon atoms. So here this minus H plus, and this bond is transferred in between these two. So this bond is transferred between these two carbon atoms, and this complex loses H plus ions to form the benzalate. To form the C double bond O and H, and this is the benzalate. Finally, this H plus ion combined with this AlCl4 minus ion, which is produced in the first step, to form the AlCl3 plus HCl. So this is the mechanism of Gattermann synthesis. This reaction is also called as the Gattermann reaction. Okay, thank you.